Hey guys, this is Michelle, and we're going to do the lesson for 2.4 and part of 2.5. There's a part of 2.5 that I don't want to miss and talk with you about in class. It's something called the three-line method. I will try to go over it a little bit here, but I want to make sure we get it done, and I don't want it to run over 30 minutes. So here we go. The first thing that we need to talk about is something called interval notation. Interval notation is a way of writing a graph in written language instead of talking about the graph itself. So what I want to go over is I want to go over what the set notation is, what the graph looks like, and what the interval notation is. Okay? So here is what the set notation would be. Then we're going to look at the graph. And then we're going to look at what's called interval notation. This whole test has interval notation on it unless it's an equation. Okay? So if I have something that's got set notation that looks like this, and we want x greater than a. Okay? Greater than a means which direction. Okay? So if I look at a graph and I've got a in the middle, greater than a means to shade to the right. Okay? In high school, you may have talked about open circles and closed circles, and if it was greater than, then you would use an open circle, and if it was greater than or equal to, you want to use a closed circle. Well, what this book talks about, and the way that it kind of helps you out when we get to interval notation, is that we're going to talk about a parentheses if you're talking about greater than or less than, or infinity or negative infinity, and you're going to talk about brackets if you've got greater than or equal to, or less than or equal to. Okay, since this problem is strictly greater than, what we're going to look at is putting a parentheses on A. So it would be parentheses and then everything to the right. Okay, now if you think about the number line and you read from left to right, the number line starts down here at negative infinity and it goes all the way to infinity. Okay? So the way that looks in terms of interval notation is that you're reading your graph from left to right. So where does my graph start? Well, it starts at A and it goes to infinity. Okay? Now, what was the symbol that we placed on A? It was a parenthesis. So we're going to put parentheses A. And then infinities always get parentheses because you can't ever equal infinity, because it's like Buzz Lightyear, to infinity and beyond. So that it's always parentheses on infinity because you can never equal infinity. Alright? So, let's look at set notation if I have x greater than or equal to a. Alright, so same kind of deal. We have a greater than or equal to means I'm going to shade to the right. But this time, since I've got greater than or equal to, I'm going to use my bracket on A. Alright, so when I look at the interval notation, it goes from A to infinity, and then A gets a bracket, but infinity always gets the parentheses. Okay? Next, let's look at less than. If I have x less than A, it's going to be to the left, less than, but there's no equal to sign, just strictly less than, so we're going to go and put a parentheses there. Okay? Now, reading from the graph, negative infinity on the left, infinity on the right. So if I start this graph, it comes from negative infinity and it goes to A. Parentheses on the infinity and parentheses on the A. Alright? X such that we're less than or equal to A. Less than or equal to, so we have less than shading to the left. This time it's got the equal to, so we're going to put a bracket. And if we read from left to right, it starts from negative infinity and stops at A. Infinity always gets a parentheses and A gets a bracket. Okay? Hold on, guys. I gotta meet with a parent.
Hey, how are you?
Fine. How are you?
Good, good. I'm Ronnie. I'm
Yep, Josh's mom.
Yes, ma'am.
Josh is doing great.
Okay.
I'm mad that he dropped calculus, but it feels on it for him.
Yes, ma'am.
And he was out for a couple of days and missed a quiz, but he made that up already.
Okay.
And I think he made an A on his test that we took yesterday.
Yeah, he told me.
So he's doing great.
Okay.
So I can't complain. Just wish he had stayed in calculus, but I understand the reasons why. So anything else I can do, seems great.
You got it.
How you doing?
Good. I passed that class today.
Awesome. All right. It was good to see you again.
You too. Take care.
All right. Sorry about that, guys. Parent-teacher conferences. All right, now let's do between. So if I want to do between two numbers, let's say that I had strictly between A and B. Okay, so I've got A on the left, B on the right. So see how the X is trapped between the A and the B? So your graph is going to be trapped between A and B. And just like we had with strictly less than and strictly less than before, we're going to put parentheses on those.
Better be listening. You get some extra help.
So we're going to look at negative infinity to positive infinity. Okay, now see how the negative infinity is not touched and the positive infinity is not touched? The graph only goes from A to B. So we're just graphing right there. Alright, so let's just play with that for a second. What if I had less than or equal to and strictly between less than or equal to X, less than or equal to B? So same deal. Here's my A. Here's my B. And since both of them are less than or equal to, less than or equal to, it's trapped between the A and the B. And we're going to put a bracket. Okay? Bracket on A and B. So if I'm looking at the interval notation, it's A to B, and we're going to put brackets. Alright, now, the next thing that I just want to kind of talk to you about, because one of the problems that we deal with later is one such that you get an answer that it's all real numbers. So the graph of that, if I had an A or a B in it, it doesn't really matter. Because it's all real numbers, the entire number line is getting shaded. Okay? So I've got negative infinity to infinity. And so that interval notation would be from negative infinity to infinity. Alright? The other situation that we have, that we come up on later, is the empty set, where something doesn't happen. So if it doesn't happen, then nothing gets shaded. Alright? I have an empty line. Nothing shaded. So it would just be the empty set. Okay? We're going to come upon each one of those situations in the work that we do with this test. Alright? So let's go and graph a couple of real examples. So, if I have x such that x is greater than or equal to 5. Alright? Y'all don't get real fancy with these number lines. Just put the number on there. I know the numbers to the left and to the right of 5. So just make it real simple on yourself. Alright, the first thing that I know is that greater than means to the right of. So I'm going to shade to the right of 5. And because it's greater than or equal to, the 5 is going to get a bracket. And if I want to do interval notation for that, real simple, it's going to be a bracket on the 5, and it goes to infinity with a parentheses. It's like reading from left to right. When you read a book, you read left to right. So when you read a graph, it's left to right. And when you read interval notation, it's from left to right. All right, let's do another one. What if I've got x such that x is less than negative 3? Okay, put negative 3 in the middle. Less than is to the left. Alright, so I'm going to shade to the left. And since it's strictly less than is a parentheses. So I'm going to look at my interval notation for that. The interval notation would be from negative infinity, which gets a parentheses because infinities always get parentheses. And negative 3 is where it stops, and negative 3 gets a parentheses. Alright, one more for good measure. X such that it's between negative 2, less than x, less than or equal to 5. Now I didn't do this one in the general rules, but I think we can figure it out. Alright, so we've got negative 2 and 5. Okay, so it's between negative 2 and 5, so we've got that shaded, okay. And since negative 2 is less than, strictly less than, the negative 2 is going to get a parentheses. And the 5 is less than or equal to, so it's going to get a bracket. So my interval notation would be from negative 2 to 5. And negative 2 gets a parentheses, and 5 gets a bracket. Okay? Any questions about those, just email me and let me know. This whole test, like I said, if it's got an inequality sign, you're going to have to give me the interval notation for it. Alright, so let's solve some equations. What if I had x minus 5 less than or equal to negative 2? Alright, so if I want to solve this equation, the first thing I'm going to do is I'm going to add 5 to both sides so that I get x less than or equal to 3. Well, that's something that's really simple. I'm going to do 3 less than or equal to is to the left. So I'm going to shade to the left, and 3 gets a bracket. And of course, we're going to have to do the interval notation. So the interval notation would be from negative infinity, which gets a parentheses, and it stops at positive 3, and positive 3 would get a bracket. Y'all, these equations go from really simple on the homework to some pretty difficult ones. So just take your time on that. The next thing that I need to talk to you about is what happens if we multiply or divide by a negative. So let's do this in the form of an equation. Let's say I have 4x minus 6 less than 6x. Alright, you remember in the last chapter I said make sure you take all of your x's to the left hand side. And this is the reason why. In this test or in this chapter, it's easier for you to look at the equation or the graph if the variable is on the left hand side. If it's on the right hand side, you kind of have to do a little bit of twisted thinking. So it's easier if you get things on the left hand side. So let's do that. So the first thing I'm going to do is I'm going to subtract 6x from both sides. So I've got negative 2x minus 6 less than 0. So let's add 6 to both sides. So I get negative 2x less than positive 6. The next thing that we would do is we would divide both sides by negative 2. And we get negative 3. Okay, now the rule is if you divide by a negative in an inequality, it flips the sign of the number and the inequality. Alright, so this will go through a change because we divided by that negative here, and it's going to flip that less than sign to a greater than sign. Okay? So when I come to graph that, instead of being less than is like we would think up here, up above it, greater than is to the right, and it gets a parentheses, and my interval notation would be from negative 3 to positive infinity, close parentheses on the left and parentheses on the right. Okay, that's a kind of hard concept for you to understand. All right, so let's do another one of those. What if I had negative 2/3 x greater than or equal to 6? Okay, I know y'all, you don't like the fractions, so let's get rid of them. So the first thing I'm going to do is multiply both sides by 3. So that I get negative 2x greater than or equal to 18. Then I'm going to divide both sides by negative 2. And because I divided by a negative, that inequality sign flips. And I'm going to flip the sign of the number I divide by. So 18 divided by negative 2 is going to be negative 9. So that when I do the graph, I get negative 9, and less than or equal to 2 would be to the left, and it gets a bracket, and the interval notation would be from negative infinity to negative 9, and negative 9 gets a bracket. Okay? That's pretty important. Just wanted to make sure you understood when you do that. So let's do one where the equation is not so nice. What if I have 5 minus 3 times 2x plus 4 greater than 7x minus 9? And y'all, this could turn out to be very pretty or it could turn out to be very ugly. And just let me say that when I worked through the homework problems, and I did that already, there are some pretty answers, but there are also some very ugly answers. So just make sure that you're aware of that. And just leave them as fractions. Now, this was a problem that I saw on the test when I graded it. Y'all sit there and went ahead and multiplied and subtracted 5 and 3 and got 2. According to the order of operations, do you do subtraction or do you do the multiplication that's there first? According to order of operations, you have to do the multiplication first. So the first thing that I have to do is I have to distribute that negative 3 across there. All right, so I'm bringing down the 5. Now, negative 3 times 2x is negative 6x, and negative 3 times 4 is negative 12, greater than 7x minus 9. Alright, so if I combine like terms on the left-hand side, I get negative 6x, and 5 minus 12 is negative 7, greater than 7x minus 9. So the first thing I'm going to do is subtract 7x from both sides. And I get negative 13x minus 7 greater than negative 9. So the next thing I'm going to do is I'm going to add 7 to both sides. So I get negative 13x greater than negative 2. Now I'm going to divide both sides by negative 13. Alright, and because I divided by a negative, that greater than sign is going to become a less than sign, and I've got x, and a negative divided by a negative is a positive, so I've got positive 2 over 13. And again, don't be afraid to get some of those nasty looking fractions. They were some not so pretty fractions on the homework. Alright, so less than 2/13 would be to the left. 2/13 is strictly less than, so it's going to get a parentheses. And my interval notation would be reading from the left, would be negative infinity to 2/13. Infinity always gets the parentheses, and this time the 2/13 gets a parentheses because it's strictly less than. Alright, let's look at the next problem. What happens if I have between two things? Alright? Let's say I have negative 5 less than or equal to 2x plus 3 less than 7. Alright, if I covered up everything to the left of 2x, and I just had 2x plus 3 less than 7, the way I would solve this equation would be to subtract 3 from both sides and divide both sides by 2. Alright? And that's exactly what you're going to do, but remember the golden rule, what you do to one thing, you have to do to each and everything. So if I subtract 3, I'm going to subtract 3 from here. I'm going to subtract 3 from here. And I'm going to subtract 3 from here. It's like having 3 sides to the thing. Alright, so negative 5 and negative 3 give me negative 8. Less than or equal to 2x. The 3's sum to 0. And 7 minus 3 is 4. The next thing I would do would be to divide by 2. So what I do is divide by 2 here. Divide by 2 here. Divide by 2 here. So I get negative 4 less than or equal to x less than 2. Alright, now see how x is trapped between negative 4 and 2? So when I come to the graph, I get it trapped between negative 4 and 2. And on the left-hand side, it's got less than or equal to, so I'm going to put a bracket. And on the right-hand side, it's got a strictly less than sign, so I'm going to put parentheses. So the interval notation would be from negative 4 to 2 with a bracket on the left and a parentheses on the right. Now, when you look through this problem, since I've got it vertically like I do here, you should be able to see the bracket here. I should be able to look up and see a bracket, and then I can see the less than or equal to sign. And on the right-hand side, I see a parentheses, and then the strictly less than sign. Okay? They should match up. That's all of section 2.4. Okay? 2.5 is still dealing with inequalities, but this time we're going to add some things. We're going to talk about sets of numbers and how they are and or, and something called the 3-line method. All right? I'm going to do the 3-line method if the section 2.5 homework is due this weekend. I'm going to move the date back because I just don't feel like it's something that I can talk to you about on a video and you kind of understand it. I'm going to go through it for 1 or 2 examples, and then on Tuesday in class I'll come back and I'll redo those examples. Just know that we're going to have a very fun-filled pack worth of information because I then have to do section 2.6 and 2.7. This test only has 17 problems on it, and I've covered probably 5 or 6 problems already. So you need to know that there's 11 more problems and problem types that I need to talk about. So don't be ready for a fun-filled day on Tuesday. So let me do this 3-line method with a couple of problems. What we need to talk about is and or. All right, and the way that they do this in the homework is they give you a set of numbers. Okay, so I'm just going to say 1, 2, 3, 4, 5. And then I'm going to put B as the set 3, 8, 9, and 11. All right, couple of ways to say that. A or B, and it's written as A union B. It says what's in both sets, and you put them together. If it's a union, it's 2 separate things coming together. So A union B would be everything that's in set A, 1, 2, 3, 4, and 5. And then it's everything that's in set B. But I don't need to rewrite the 3 because it's already here. Everything that's left would be 8, 9, and 11. So A union B would be the set 1, 2, 3, 4, 5, 8, 9, and 11. Okay? The other thing that we talk about is what's known as A and B said in language, but in symbols it's A intersect B. Intersect says what do they have in common? Okay, so what do set A and set B have in common? All right, the thing that they have in common is the number 3. So only the number 3 would be in the intersection. Okay? So what we need to do is look at, let me look at one more, and then we'll go on to the 3-line method. Alright? Let's say that A is the set that X is an even integer. and B is the set 10, 11, 12, 13, and 14. Okay? So, A union B would be everything that's in the set of A, so it's all of those X is an even integer. Okay? So that covers some things over in set B. So it covers the 10, the 12, and the 14. So that means I don't need to write them down again. So what I'm going to say here is that it's X is an even integer, or X can be 11, or X can be 13. Okay? And that's how you would write A or B. Now, when we look at the intersection, we have to look and see what they have in common. And it's kind of just, we've already done it, really. Even integer, and in set B, what are my even integers? Well, we've got 10, 12, and 14. So those would be the numbers in the set A intersect B. Now, how does this get into a graph? Okay, so I'm going to do one of those examples, and then we'll stop there and I'll pick up on Tuesday. Alright, the way this is set up is set up in terms of 3 lines, okay? They don't get real fancy. It's 3 lines with 2 numbers, 2 vertical lines, okay? The first number, or the first line, is for the first part of the problem. The second part of the second line is for the second part of the problem. And then the third line is for your answer. Okay? Which is the thing that goes right there. Alright, so what you're going to do is graph each one. So, first thing I'm going to do is put these 2 numbers on a number line, and I'm going to put them from least to greatest. So I have 5 and I have 11. The next thing I'm going to do is that I'm going to graph each one separately. So greater than 5 is a parentheses to the right, and it gets a parentheses. All right, less than 11 would be to the left of 11, and it gets a parentheses. All right, and means what they have in common or where they intersect. If you look at this graph, they intersect here. All right, so when I come down to do my answer, it's going to be the red part that I shaded where they intersected, which is between the 2, and then you just keep the same symbol. So this one gets a parentheses, and this one gets a parentheses. So it would be from 5 to 11. All right, let me do another and problem, and then I'm going to stop there because or is a whole nother deal, so that y'all tend to get confused with that. So I want to make sure that we do that one together. All right, let's say I had greater than or equal to 2 and m greater than 7. Three lines. M greater than or equal to 2, m greater than 7, and then my answer. Okay? So, greater than or equal to 2 would be a bracket shaded to the right. M greater than 7 would be a parentheses shaded to the right. Now, where do they intersect this time? And y'all always think that they intersect in the middle, but they don't here. They intersect in this part. Alright, so if I go down to do my shading for the answer, it's going to be just this part. I have to leave this part out. Alright, now what's the symbol? Well, it drops down from wherever I start, so it gets the parentheses symbol. So it goes parentheses 7 to infinity. That's pretty much an introduction to the 3-line method. They're kicking me out of school now because they're redoing the floors, so I have to leave. But I want to make sure that everybody understands that the 3-line method is all through this test. If it's an equation or an inequality, strict inequality like we talked about at the beginning of the lesson, then it's just one line and you get one line for the answer. Don't set up 3 lines. There's not 3 lines set up for you on the test. Now, when you're doing the homework, it would be better if you set up your problems with the 3-line method. Not necessary because it's on the computer, but necessary when you take the test. So make sure that when you're practicing with the 3-line method. I'm going to stop there and I will see everybody on Tuesday. Thanks.